Morning, Year 9. I wanted to speak to you this morning about standard form and just make sure that you're okay with the idea. So the basic idea is it gives us a way of writing both very, very big numbers and very small numbers. That's really useful in science, physics and chemistry, etc. We'll just make sure you're okay with the idea. So we'll have a look at a question. It's a really simple thing to do. And the idea is that you're going to say it's a number times by 10 to the power something. So I'm going to do it wrong to begin with. So some students do this, and I think if we get this out of the way straight away, I think that would be really useful. Some students, when they're first doing this, will say, oh, well, that's 23 times 1,000, and the quick way of saying 1,000 is 10 cubed. Now, what they've written is correct, in that that is 23,000, but it's not written in standard form. So standard form is just an agreement. We're all going to agree that the way we do it is that the first number should be bigger than 1, or 1 hour bigger than 1, but less than 10. So this is too big. So the idea is that when you write your number, you're going to put a decimal point, and you put it in the same place each time. It just comes in after the first digit. In other words, it will be a number 1 or more, but less than 10. It does mean that this bit here isn't 3, but it would be 2.3 times 10 to the 4. What we want to do is to make sure that we've got a really quick and simple way of going from here to here, the correct answer. I just want you to look at something. 1, 2, 3, 4. If I count all these digits but stop before the first one, I get that number. So I'm just going to not just count the zeros, but count until I get to the first number. In other words, it's 1 less than all of these digits. So let's do some examples. First one we've got then is 57, gosh, big number, 1,000, million, billion, 57 billion. Step 1, write down the numbers. So you're just going to write 57. And you're going to have times 10 to the power something. The next step is to put your decimal point in, but there's no choices here. It just goes in after the first digit. So the first bit is really easy because it's the same thing each time. The next bit is to count not just the zeros, remember, don't make that mistake. You've got to count all of the digits, but not including the first one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's your answer, 5.7 times 10 to the 10, written in standard form. Right, have a go at this one. We've got 340,000. Just stop the video, pause the video, have a go yourself, and then we'll go through it. Okay, step 1, just write the digits, but don't do any more. If there's zeros, don't include any of the zeros. And then you're going to put a times 10. Step 2 is you've got to put a decimal point after the first digit, so it's always the same thing. The next thing is you've got to get this power right. 1, 2, 3, 4, 5. And that's done. It's finished. Effectively, what you're doing is you're moving the decimal point sort of from here to here. So it's 1, 2, 3, 4, 5. But don't need to worry about that. The technique is really, really simple. I want to make sure that you can do that technique. Okay, pause the video and have a go with this one. Now in this one, you write 501. That could throw a few people because of that 0, but you just stop when the rest are all zeros. So don't just stop after the 5 times 10. Step 2 is put the decimal point in. It's always after the first number. And the next one is just count these digits. 1, 2, 3, 4, 5. And you can put your 5 in there. So remember, you count the digits. It's not all of them. You just need to stop when you get to this before the first one. Okay, let's have a go with another one. Again, just pause the video and have a go yourself. So let's do it then. You've got, write the number, which is 23, and then times 10. Put your decimal point in, so it's a number between 1 and something less than 10. So it always comes after the first number. And count these digits, 1, 2, 3. And there's your answer, 2.3 times 10 to the 3. That's saying 2.3 times 1,000. And 2.3 times 1,000 is 2,300. It all makes sense. Now then, What can happen sometimes in the exam is they can give you sort of not a terribly big number, and it seems a strange thing to do. So that can actually throw people a bit. So the last one we're going to have a go at is this one. So just pause the video and have a go with that one. So in a way, even though it's a smaller number, it can cause a few problems. But let's have a go with it. You just write 27, but stop there, times 10. That's step 1. Put your decimal point in. It always goes in the same place. And do the same thing. Just count the digits. 1, 2 of them. So you've got 2.7 times 10 to the 2. In other words, 2.7 times 100 gives you 270. Okay, well, we said standard form was a good way of writing both big numbers and small numbers. So we look at small numbers. Now, I think this is actually easier to do, even though it's much more sophisticated and harder to understand. To actually do it, I think is really, really easy. So it's well worth making sure that you can write small numbers in standard form, because the technique is really simple. So what we do is just ignore all the noughts and write down the number like we did before and put times 10. So step 1 is exactly the same. In fact, step 2 is exactly the same as well. You just put a decimal point after the first digit. So it's always a number between 1 and 10. So it fits that same pattern. It's just that if I'm, instead of counting the digits like you did before, all you do is count all the zeros. 1, 2, 3, 4. Just think that's really easy to remember. So you put in the 4. Now then, that isn't quite finished yet, because 3.2 times 10,000 is certainly not that number. But it turns out that if this power is negative, this whole thing becomes the same as dividing by 10,000. You don't need to worry about this at this stage. It's just you've got to think with small numbers, you can write a negative power. So let's have a look at another one. Let's go through this one. You ignore all the noughts and then write down the number, just like we did before, and put times 10. So step 1 is the same as with big numbers. Step 2 is the same as with big numbers as well. Just put your point in. But step 3 is slightly different. Just count the zeros. But it's got to be a negative. It's not 7.51 times 1,000. It's actually 7.51 divided by 1,000. But it turns out that 10 to the minus 3 is the timesing by 10 to the minus 3, is the same as dividing by 1,000. Let's see if you can have a go at one. So, like we did before, just stop the video, pause the video, have a go at writing this number in standard form, and then just resume the video. Okay, step 1, 82. Just ignore all the noughts and write down the number, then put times by 10. Step 1 is the same as for big numbers. Step 2 is the same as big numbers, just put a point in there. All of that's automated. You want to try and automate that bit so you're not having to think about it. This next part, count the zeros, 1, 2, 3, 4, 5, put them in, but remember you've got to put a negative sign in. Now 10 to the 5, of course, is 100,000, and it's not 8.2 times 100,000, it's 8.2 divided by 100,000, but it turns out that if you put a negative power, it's the same effect as dividing by 10 to the 5. Okay, this last one we're going to have a look at is a little bit harder than the others, so pause the video and have a go at this one. Okay, let's have a go. The reason why I say it's a bit harder, it's not really, it's just that that zero might throw a few students. They might sort of just write 5 and think, oh, I've got to stop when I write a 0. You just keep writing all of them, so just ignore the first sort of run of zeros and then write the rest of the number 501 and then put times by 10. What do? You put a point after the first digit each time. Just count the zeros, 1, 2, 3, 4, and put those in. But remember, it's not times by 10,000, it's divided by 10,000. How do we do that? We just put a negative sign in that index. Now, you can stop the video at this point if you want to, but if you want to know why it is that the negative power works, then you can just carry on watching, but you don't have to. If you feel like you don't need to know that, don't worry about it. If you're at all like me and you kind of, you sort of think, hang on a minute, why is that working? We're just going to recap over a few things. This expression here, this thing, is called a power. The entire calculation is called a power. Just in the same way as that if we had 2 times 3, that entire thing is called a multiplication. This is called a power. And the little number there is called an index. Some people call them powers as well. I like to call the whole thing a power, and then this number here an index or exponent. Now then, 10 to the 3 times 10 to the 2. That result, I think, is fairly straightforward. It's just 10 to the 5. And we don't need too much convincing of that. That was 1,000 times by 100. So this is 100,000. In other words, we have a rule for multiplying powers. It's add the indices. But it also gives us another result. Really quickly, 10 to the 5 divided by 10 squared. Let's just have a think about that. 10 to the 5, that's 100,000 divided by 100 is going to be 1,000. In other words, 10 cubed. That's not such a big surprise because it's just a rearrangement of this one. 1,000 times 100 is 100,000. 100,000 divided by 100 is going to be 1,000. But it gives us our second rule. When you're dividing powers, you subtract the index. But just have a look at this. If you had 10 to the 5 times by 10 to the minus 2, just have a think about that for a minute. What's the rule for multiplying powers? You add the indices, and that would be 10 to the 3. In other words, these two calculations, just have a look at that. You can pause the video and just have a look at that and just make sure you understand what's going on. These two things are the same thing. In other words, another way of saying divided by 10 to the 2 is to say times by 10 to the minus 2. So that's why when we get these negative indices here, it's the same as a divide.